Hi everyone, we're talking about arithmetic sequences and series today, and we'll start with a definition. So a sequence is called arithmetic when the difference between each term is constant. Okay, and so what I mean by that is I should be able to take any term and subtract the term that came right before it, and I should get the same number every time. Right, so one way that we can define that recursively is any new term is going to be the term right before it, the previous term, plus some difference, say some common difference that we're going to find. Okay, and just another way of writing this same thing is that that common difference will always be some term minus the previous term. Okay, so remember a sub n just means it's a term, the nth term, and a sub n minus 1 is going to be the term right before that, or the a minus 1th term. Okay, and another way that we can define this, and this is really going to be more useful because this is the iterative way to define an arithmetic sequence, is it's going to be the first term plus n minus 1 times d, where d is the common difference and n is whatever number I'm plugging into my function. Okay, and we'll just define where d is called the common difference. Okay, so let's go through an example. First, I'm given a sequence 4, 6, 8, 10, dot, 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 and I'm asking if this is arithmetic, show why or why not. So I'm going to subtract. So 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is 2. Okay, so every time I subtract a preceding term from the current term, I get the same number. So yes, my common difference is 2, and my first term is 4. Okay, it's going to be really useful to know your first term and your common difference because then I can define my sequence iteratively. So I'm always just going to write my common difference if I can find it, and then my first term. Okay, next I am asking to show that this given sequence is arithmetic. Okay. Well, first I need to find my first term. Okay, that's what we just talked about. So if I plug 1 in, I get 4 minus 1, which is 3. Okay, and just to see, I'm going to find my second term. Okay, so the reason why I found my second term and my first term is because I should be able to subtract my first term from my second term, and if I do that, I get negative 1, because 2 minus 3 equals negative 1. Okay, so what I'm saying is if I take any term and subtract the number that came right before it, I should always get negative 1. The way that we're going to test that is we're going to find the nth term, which they gave us, it's 4 minus n. I'm going to find the nth term, and I'm also going to find the n minus 1th term, or the term right before it. Okay, so a little bit weird, but I'm finding the nth term and then the n minus 1th term. The reason why I have to do this is because I have to keep everything in very general terms. Okay, in this way, n can represent any number, and so that's why this could be considered a proof. Okay, you cannot prove something just by plugging in random numbers, because then you'd have to plug in every number. But in this way, n can represent any number. So if I plug in n minus 1, I get 4 minus n plus 1, or 5 minus n. Okay, so this was my nth term. This was my n minus 1th term. So what I should be able to do is I should be able to subtract my n minus 1th term from my nth term, okay, because this came right before it. So I should be able to subtract whatever I got here from my nth term, and I should get negative 1. So let's test that. Okay, so all I did was I subtracted what I got here from my nth term. So in this case, I get whoa, that's a 4. 4 minus n minus 5 plus n. All right, so here my n's are going to cancel. I get 4 minus 5, which is negative 1. And this is going to be my common difference, is negative 1. And this does match with what I got here. The only reason why I did this here was just to get an idea of what to expect, and I did indeed get that. Now, if this didn't work out, then it probably wouldn't be arithmetic. But I did get my common difference. I did get my first term. That's what I was asked to do. All right, next example. I'm given that the 8th term of some sequence is 75, the 20th term is 39. I want to find the first term and the common difference. Okay, so here's some things I know. Going all the way back to my equation, I know that any term in an arithmetic sequence is the first term plus the n minus 1 times d situation that I have over here. Okay, well, I can define both of the terms I'm given in this way. I know the 8th term is 75. So I know a sub 8 equals whatever my first term is. I don't know what my first term is. Plus 8 minus 1 times my common difference, which I don't know what that is either. And I know that this is equal to 75. Okay, all I did was I took my general form of an arithmetic sequence. I plugged in 8 because that's what they told me. They told me the 8th term is 75. I can do the same thing for the 20th term. So I know that a sub 20 is my first term plus 20 minus 1 times d, and I know that this is equal to 39. Okay, well, if I look at this right here, I have a system of equations. Okay, so I have a sub 1 plus 7d equals 75, 7d, not 70. And then I have a sub 1 plus 19d equals 39. I have a system of equations with two variables. So you could solve this however you want to, but we'll end up getting a sub 1 equals 96, and my common difference is negative 3. Okay, so my first term is 96, my common difference is negative 3. And this is important because I can use this to write my iterative equation. Hey, now they ask us to write a recursive formula, so that was also given up above. So the way that you can write any recursive formula is you take basically this formula and you plug in your common difference. So I know that any term in a recursive formula is the previous term, and then I plug in my common difference, which is negative 3. Hey, but the only way that this is going to be useful is if I have a starting point. So I also have to give my first term, which is 96. Okay, if you just gave this without giving any of the terms, that'd be totally worthless because we need at least one term to start. Okay, if we have the first term, then at least we can find the second term. Okay, and then the last question is what is the nth term of this sequence? Well, that's going to be my general equation. So that's my a sub n equals a sub 1 plus n minus 1 times d. So a sub n is going to be a sub 1, which is 96, plus n minus 1 times d, which is negative 3. Okay, now we could reduce this, but I'm choosing not to because this way I can see very clearly 96 is my first term, negative 3 is my common difference. Okay, that is it for this video. I will see y'all later.